Welcome to the 29th video lecture of Quantitative Techniques, module number 2, semester number 3. In today's video lecture, we're gonna continue where we had left off in a previous video lecture, that is some simple problems on probability. I hope you are understanding the problems that we are solving. They are quite straightforward and simple. Let us begin with today's examples. So we have solved the first 7 problems so far in our video classes. Today we shall take problem number 8. The problem number 8 also deals with dice, but the trick is here we have a pair of die, that is 2 dice. So let us see the problem. A pair of die is rolled once. What is the probability that the sum is equal to 9? Both the dice show same number, that is both when you roll the dice, both the dice so show the same number up. Either it can be 1 1 2 2 3 3 4 4 5 5 or 6 6. And then I've added one more problem which was not there. Here it is, that is the product of the numbers is 36. If you can see this, I'll just zoom it and show you. The product of the numbers is 36c. Okay, so let us start solving this problem. The problem is actually quite straightforward. First we write the experiment. Here experiment is rolling of a pair of die. Then the sample spaces. See, if two dice, that is a pair of die, is rolled, you should know by heart that the number of items in the sample space should be 36. So if you want, you can write the sample space. It's always recommended that when a pair of die is rolled and that experiment is given, you write the sample space. But if it comes for only 2 marks, then it's okay if you don't write the sample space. If it comes for 5 marks, you have to write the sample space. Okay, so the sample space is like this. It's quite a big set. So it starts with 1 1 2 1 2. See here, in this entire this I have one fixed 1 here. The other dice is changing. 1 2 3 4 5 6. In the second one I fixed 2 and the other one is changing. 1 2 3 4 5 6. Now in the third one I fixed 3 for the first die and I am changing the second one. 1 2 3 4 5 6. Now I fixed the fourth one here, that is the first die, that as 4. So 1 2 3 4 5 6. Now in the fifth row, that is I fixed the first die as 5 and I'm changing the second die. 1 2 3 4 5 6. And in the last attempt I've put it as 6, that is I've fixed it as 6, the first die, and the second die I'm changing. 1 2 3 4 5 and 6. So this is how I have changed this. So the total sample size is n equal to 36. I hope you have understood this. Whenever a pair of die is rolled, this is how you have to write the sample space. You are fixing the first number of the dice, that is this. If you see 1 2 3 4 5 6, and here you change the second numbers, that is 1 2 3 4 5 6, 1 2 3 4 5 6, 1 2 3 4 5 6, and so on. So totally you will get 6 rows, 6 columns, 6 6 are 36. So n of s is equals to 36. Fine. Now let's move ahead. What is the first event? Let's go to the question. The sum is equal to 9, it says. Okay, sum is equal to 9. Event A. So event A says that the sum is equal to 9. Now you have to find out all those numbers from this set where the sum is equal to 9. Now just see where is the sum equal to 9. Here the sum is total, that is addition. 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, here 5, 6, 7, total is 7. Here the total is 3, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8. For the first time I'm getting the sum is equal to 9. So here 6 plus 3, that is 3 plus 6 is 9. Then again if you see, I am getting this, this and this. Apart from this, if you check, there is nowhere where the sum, that is the total of numbers that you got on the dice, is 9. So only 4 items you are there where the sum is equal to 9. So that will be your set A. So from sample space only we are taking always, remember that method remains the same. So sample space I have written, then set A, only 4 items I am getting, and those 4 I am writing here down. So these are the 4 items. Now once you get n of a equal to 4, the remaining method is same. P of a is equals to n of a upon n of s here. So n of a is nothing but 4 and n of s is nothing but 36. So 4 upon 36, which is nothing but 0.111. You can either keep it as a fraction or keep it as decimal, it is up to you. Okay, so the first one was quite easy. The second one we'll see now. Now what about the second one? The second one, both dice show the same number. Now both dice should show the same number. When will this happen? If you see, look at this sample space again. When are the dice showing same number? So it is here 1 1, 2 2, 3 3, 4 4, 5 5 and 6 6. So apart from these 6 numbers, the dice are not showing same number, they are different numbers. So n of b, that is the value of n of b is 6. 1 2 3 4 5 6. 6 numbers are there. So 6 instances are there where the number is same. So 1 1 2 2 3 3 4 4 5 5 6 6 is your set b. So n of b is equal to 6. N of p of b, you have to find out. P of b is equals to n of b upon n of s. N of b, you know, it is equal to 6. N of s, we know that it is equal to 36. So it is 6 upon 36, that is equal to 1 upon 6, or it is equal to 0.1666666, that is nothing but 0.167. Okay, so this is your event b. Now what is your event c saying? Event c says that the product of the numbers is 36. I have to, okay, the product of the numbers is 36. So when will be the product of number 36? So you can just check what is the product of the numbers there individually. 1 1s are 1, 1 2s are 2, 1 3s are 3, 1 4s are 4, 1 5s are 5, 1 6 are 6. So 2 1s are 2, 2 2s are 4, 2 3s are 6, 2 4s are 8, 2 5s are 10, 2 6 are 12, 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12, 3 5s are 15, 3 6 are 18, 4 1s are 4, 4 2s are 8, 4 3s are 12, 4 4s are 16, 4 5s are 20, 4 6 are 24, 5 1s are 5, 5 2s are 10, 5 3s are 15, 5 4s are 20, 5 5s are 25, 5 6 are 30, 6 1s are 6, 6 2s are 12, 6 3s are 18, 6 4s are 8, 24, 6 5s are 30 and 6 6 are 36. So only one value you have where the product is equal to 36. So note down that value. So n of c becomes equal to 1 because you have only one value. So again the same thing, n of p of c is equals to n of c upon n of s. N of c, we know that it is equal to 1, so it is 1 upon 36. N of s remains the same, so it is equal to 0.028 if you solve it. Okay, so this is about this problem. This was quite straightforward, not much difficulty. And then we are moving towards the next type of problems, that is playing cards problem. So we shall solve playing cards problem today. The ninth problem goes like this: a card is drawn from a deck of playing cards. Okay, from a set of playing cards, that is, total number of cards are 52. So from those 52 cards, which do not include joker or anything else, so from those 52 cards you are drawing a card. What is the probability that the card drawn is A, an ace, B, a face card, C, a heart, D, a black card, E, queen or a spade card, F, a red card or a king? Okay, so let us start solving this experiment. What is the experiment here? Experiment is drawing of a card. Okay, there's no problem with the experiment. Now don't write the sample space here for cards, because you have to write 52 items. It becomes very hectic. Okay, so n of s, we know 52 cards are there, only one we are gonna draw, so chances are that it can be any of these 52. So n of s is equals to 52. Now A, let us see what is event A. Event A is an ace. They have given here an ace. So we are finding out what is the probability that it is an ace. Now what is n of A equal to? N of A equal to 4. Why 4? Because how many aces you have? Ekka, how many aces you have? It can be a spade ace, it can be a clover ace, it can be a diamond ace, or it can be a what is the remaining one? Diamond, heart, spade, or clover ace. So one of these four aces are possible, so only four aces are there, so n of A equal to 4. So probability of A is equals to n of A upon n of S, which is equal to 4 upon 52. 4 is comes from here, 52 comes from here. Okay, so which is equals to 1 upon 13, which is equals to 0 0.077. So event A was quite easy. Let us go to event B. Event B says that it is a face card. So how many face cards are there? In a previous theory class, I had told you that there are total of 12 face cards, 3 in each set. That is the jack, the queen, and the king. So 3 face cards, totally 12 face cards are there. So we know that event B, when it comes to face cards, n of B is equals to 12. 12 face cards are there, that is 3 in each. I have explained here, 3 in each. We have 3 in heart, 3 in spade, 3 in diamond, and 3 in clover. So total 3 into 4 is 12. So this is how we have 12 face cards. So n of B is 12, we know. So probability of B is equals to n of B upon n of S. So n of B is 12. 12 divided by 52. 52 remains the same because there are 52 cards, which is equals to 0 0.231. The third event we'll see. What is event C? Event C is talks about heart. It is a heart. So n of C, how many hearts are there? There are 13 hearts. One full set of hearts, that is 13 cards are there. So probability of C is equals to n of C upon n of S. N of C is nothing but 13. So 13 upon 52 it comes, total 52 cards, so which is equals to 1 upon 4, which is equals to 0 0.25. Okay, now moving to the next problem. Event D, a black card. Now what do we mean by a black card? The design that are printed on the card is black color. So we have two instances where the design is printed in black color, that is, it might be a spade or it might be a clover. So in both of these sets we have black color design, and that is why 13 plus 13, total 26 cards we have which are black in color, and the other remaining 26 are red in color. So 26 black cards we have, that is why n of D is equals to 26. 13 clover plus 13 spade. So probability of D is equal to n of D upon n of S, which is equals to n of D is nothing but 26 comes from here, and n of s remains 52, so which is equals to 1 upon 2 or it is equals to 0 0.5. You can write any of this. Now remember, whatever this I am writing here, no need to write in your examination, you can directly write this. So how this n of a, n of b, n of c, n of d has come, there's no need to write in your examination. If you want, you can write, or else you can directly, if you know, you can, I want only this in the examination. Now this is the tricky part, e and f. Just pay little attention here. What is n of e? What is event e? Event e is nothing but it is a queen or a spade. Okay, it is a queen or a spade card. So how many cards might come in this event? So n of e, how many spade cards are there? Spade cards are 13 in numbers. Okay, so spade cards, but this spade card also includes queen of spade, right? Queen of spade is already included in these 13 cards, so the remaining other 3 queens, okay, there are only 3 other queens remaining. So 13 plus 3, it is not 13 plus 4, remember, it is 13 plus 3. So total number of items in set E are 16. 13 spade cards, which includes the queen of spade plus the other 3 queens. So this is equal to 16. So probability of E is equals to n of E upon n of S, which is equals to 16 upon 52, which is equals to 0 0.3077. And today's last part will take after this. If you understood, it is similar to this one, E. So F part. Okay, what is F part? Event F, it is a red card or a king. So similar to the previous problem which we have solved, or section which we have solved. N of F, what is the number of items in set F? It is a red color card. So how many red color cards you have? It is 26 red color cards. Red cards are 26. It includes the kings of heart and diamond, right? So other two kings only are remaining. 26 cards includes the king of hearts and the king of diamonds, and we have only two other kings remaining, that is king of clover and king of spade. So these are the two other kings I am adding to that. So 26 plus 2, that is equal to 28. 28 cards you have total, which are either red color cards or it might be a king. So P of F is equals to n of F upon n of S, which is equals to 28 upon 52, that is nothing but 0 0.538. So I hope you have understood this. This was quite